Good morning, welcome to another episode of our learning. Today we're going to be looking at the LCM and the HCF of numbers. With the example on the board, I'm going to be showing you how you can solve for the HCF of any given number. And when you're solving for the HCF of a number or numbers, all what you need to do is to look at for the common possible factors. We are not looking for the LCM as of now, we are looking for the HCF. You look at for the common possible factors, and then you divide. If there is no other factor that is common between the two numbers or more than two numbers, you're asked to look for the HCF. You stop your division there. I will repeat, if there is no other possible or common factors between the numbers you're asked to look for the HCF, you stop your division right there. Now let us solve this and also solve subsequent examples for you to understand this. Now I have 24 and 30. I'm asked to look for the HCF of these two numbers. I can use my long division method of dividing numbers to get my answer. Let's go. I have 24 and then I have 30. I'll ask myself, what is the lowest possible common factor between 24 and 30? I have it to be 2 because 2 can divide both of them. 2 divided by 24 will give me 12, and 2 divided by 30 will give me 15. I will ask myself again, is there any common factor between 12 and 15? Yes, there is a common factor, which is 3. 3 divided by 12 will give me 4, and 3 divided by 15 will give me 5. I'll ask myself again, is there any common factor between 4 and 5? No, there is no other common factor. So I stop my division right here, and then my HCF will be 2 times 3, and that will give me a value of 6. So the highest common factor between 24 and 30 is 6. Now here is another example. I'm asked to also look for the HCF of the numbers 6a or of the terms 6a, 4a squared b, 12a bc. The first question I will still ask myself, what is the lowest common factor between 6a, 4a squared b, 12a bc? That is the smallest number that can divide them without leaving any remainder. Yeah, I will say that 2 can divide because 2 is a common factor. 2 divided by this will give me 3a, and 2 divided by this will give me 2a squared b. 2 divided by this will give me 6a bc. I will ask myself again, is there any common factor between 3a, 2a squared b, 6a bc? If you say 2, you are wrong because 2 cannot divide 3, and 2 is not a factor of 3a and of 3a, yeah. But 2 is a factor of 2a squared b and 6a bc, but not a factor of 3a. So we will not use 2. If I say 3 is a factor of 3a, but not a factor of 2ab squared and a factor of 6ab ABC. And since it's not a factor of 2a squared b, I won't use 3 to divide. What of a? Yeah, a is a factor here. It's also a factor here and also a factor here. So a is a common factor of those 3 terms. So a divided by 3a will give me 3. A divided by 2a squared b will give me 2ab. And a divided by 6abc will give me 6bc. Now, if you look at these 3 terms you have here, there is no other common factors there. So I'll end my division right here, and then my HCF will be 2 times a. That will give me 2a. That's my HCF of the terms 6a, 4a squared b, 12a bc. So here is another example. I have 24 mn squared and then 36m square n, and I'm asked to look for the HCF as well. Now, as we have always been doing, you ask yourself, what is the lowest possible common factor between 24mn square and 36m square n? You can see that 2 can divide because 2 is a factor of this and this. So 2 divided by this will give me 12m square, and 2 divided by this will give me 18m square n. What else can divide here? 2 can also divide because 2 is also a common factor. 2 here will give me 6n square, and here will give me 9m square n. Can 2 divide again? 2 can divide here, but 2 cannot divide here. So 2 is not a factor of 6m square and 9m square n. What of 3? Yes, 3 is a factor of this, and 3 is a factor of this. I use 3 again to divide. This will give me 2m square. This will give me 3m square n. Looking at this again, 2 is a factor here, but not a factor here, and 3 is a factor here and not a factor here. So I can use either 2 or 3 to divide. I will ask myself, what of the variables I have there? M is a factor here and it's a factor here. So let us use m. M divided by this will give me 2n square, and m divided by this will give me 3mn. Now what else can divide, or what else is a common factor between 2n square and 3mn? N is a factor here, and n is also another factor there. So I will use my n, and here will give me 2n, and here will give me 3n. Is there any other possible common factor? No, because n can divide here, n cannot divide here, so n is not a factor. So also with m, 3 and 2. So my HCF will be 2 times 2, that's 4, 4 times 3, 12, m times n, mn. So this is my HCF of the terms 24mn square, 36m square n. Now, here is another example. Yeah, well, let's say a similar example with the one we just finished 7. But in this case, we're gonna be looking at the LCM now. I've given you guys 3 examples on how to look for the HCF of any given number of terms given to you. Now let us look at the LCM of these terms. Now the approach is still quite similar to that of HCF, but the only difference there is that you simplify, or you divide each term to its lowest possible form. That is to, you get to a number whereby you cannot divide again. Let's go. I can use any factor or any number, provided that the number can divide each of them. I use the number and divide. Now let's go with 2 first. 2 can divide this and 2 can divide this. That will give me 12m square, and here will give me 18m square n. 2 again can divide, this will give me 6mn square, and this will give me 9m square n. 2 again can divide. Here I'm not looking at the HCF, and even I'm looking at the HCF, I can't use 2, but because I'm looking at LCM, I will divide every number or every term to its lowest possible form. Here will give me 3mn square. 2 cannot divide this, so I will write it back again. 3 can go. 3 here will give me mn square, and 3 here will give me 3m square n. 3 can go again. Here will give me still mn square, because 3 cannot divide this, and here will give me m square n. We have another numbers that can divide, another variables that can divide. I have my m can divide. Here will give me n square, m here will give me mn. M can divide again. M here will give me n square, and m here will give me n. N can divide. N here will give me n, and n here will give me 1. n can divide again to give me here to be 1 and then 1. Are we saying we try to simplify or divide each term to the lowest possible form for the LCM. Now, our LCM will be 2 times 2, 4, 4 times 2, 8. 8 times 9 will give me 8 times 9. M times M, that's M squared times N squared, times M squared times N squared. And that will give us 72 M squared N squared. So this is my LCM of the given terms 24M N squared and 36 M squared N. And I hope with these little examples of mine, you all can solve any given problem or any given number or any given term that you're asked to look for the LCM or the HCF. Thank you.